Well, we're going to begin with the introductory video to Chapter 2. And in this video, we're going to address two of the topics that are essential to the development of calculus. First, we're going to talk about, whoa, it's so high, rates of change and tangent lines. So we're going to get to know those a little bit better. So first of all, let's talk about tangent lines. Well, in plane geometry, we learned that a secant line is a line that intersects a circle or some other curve at two places. So you can see here at this diagram, we have a circle with a secant line, and the secant line has two endpoints. So for example here, endpoint A and B would define secant. Now tangent line, we have a diagram here of a circle, but this circle, you'll notice the tangent line intersects a circle at one point P. Now tangent lines can be demonstrated through these diagrams. A, we notice that we have a line tangent to the circle at this point here. B, we also have a tangent line that intersects the curve B at this point. Now C is an example of not a tangent line. Even though it does cross the curve, it is still not a tangent line. Now giving you those three representations, two which are tangent lines, one that is not, what I would like you to do right now in your paper is to fill in the box, and in your own words, let me say that again, what is the definition of a tangent line to a curve? So take a couple minutes to write that down. If you need more time, please press pause. I'm going to continue though, okay? Now let's talk about rates of change. So again, our topic was tangent lines and rates of change. Now before we get further into our discussion, we need to clarify a little bit of vocabulary. First of all, the symbol delta will be used frequently, and that symbol represents change. Change in a function or change in a variable. Now, two other common representations are s of t or x of t. Now, they're synonymous, and they indicate the position of an object. Or in other words, its distance from the origin at some time t. So that is position. Another common vocabulary term is net change or displacement. Again, those two words are synonyms, and these two words, their meaning is the change in position. How much, like if you're traveling miles, how many miles was your distance, the displacement from beginning to end, okay? And then the last thing that we're going to talk about is your average rate of change. Now, many times we refer to average rate of change as slope. Now, slope we know is represented as a ratio. So what I'd like you to do on your paper is I would like you to write as many different ways as you can possibly do the definition of this rate of change using a ratio. Now, I'll get you started. I'll give you one. So, for example, slope can be written as the ratio of rise over run. Okay, now I'd like you to pause the video and write a few other representations of average rate of change or slope where they are ratios. Okay, so press pause and continue your work and then play it again. Now there are 4 misconceptions about this topic of tangent lines. And so I've got 4 of them here with a graph, and we're going to illustrate what those misconceptions are. Well, the first misconception is a tangent line to a curve must cross the curve only once. Well, I'm going to draw an example that is a counterexample. So here is a line, and it crosses the curve only once at the point P. But this is not a tangent line. Now, it does cross only one point, so it met this definition, but clearly not a tangent. Misconception 2. A line is tangent to a curve if it crossed the curve at exactly one point. Well, let's say point P here. If I draw a tangent line to P, because this is a tangent line, you'll notice that actually my line crosses the curve twice. So this misconception does not hold true. Misconception number 3. A line is tangent to a curve if it touches the curve at one point, but does not cross the curve. Well, I could draw a line that touches the curve at point P. So it touches the curve at one point, but does not cross the curve, yet this is not a tangent. And last of all, A tangent line to a curve is a line that just kisses the curve at a point, but does not cross the curve. Well, again, if I look at the point P, and I follow the directions, and I draw a tangent line, notice, though, it kisses the graph, but it does cross it twice. So this is another misconception. Now, I'm going to give you a more exact formal definition. So these were our examples previous, and this was our non-example. And looking at these examples and non-example, we could say that a tangent line to the function f of x at the point where x equals p is a line that touches the graph of the function at that point and is parallel to the graph at that point. So if you look at example A and B, do those examples meet this definition? They touch it at that point and is parallel to the graph at that point.